Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at securing wireless LANs. We'll be discussing SSID cloaking and MAC address filtering, 802.11 origin authentication methods, shared key authentication methods, authenticating a home user, encryption methods, authentication in the enterprise, and finally, we'll look at WPA3. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. The problem with wireless LANs is they're wireless. It's a double-edged sword. Yes, it's a good thing they're wireless. It gives you mobility, but it's also a bad thing that they are wireless. That means anybody that can hear that signal, they could compromise your network. And so we have to secure that network somehow. A couple of the ways we do this is what we do early on is what we call hiding our SSID. We did SSID cloaking. Instead of broadcasting saying, okay, we have these networks for you to available. So when you open up your device and you hit wireless networks and it lists out those networks, what we did is we essentially hid those SSIDs. And it's not really hiding. What we did is turned off the feature to show it. We unchecked that little box that says show the SSID. We unchecked it. Now, if you were a threat actor, there's software out there that's, even though you don't advertise your wireless network, they could still see your wireless network. And so that's why it was early on, it was good, but nowadays, most people, they can easily bypass that. We could do MAC filtering, only allow certain clients, certain MAC addresses onto our wireless network. You as an administrator, that is a lot of work on your end. You have to make sure you add in the right MAC addresses. You have to make sure you type those MAC addresses in. 12 hexadecimal numbers you have to type in for every end user device. It's a lot of work, and typing that in, it works. It's a good solution, but you can actually change your MAC address. You're not supposed to be able to. It's supposed to be burnt into a chip on your network interface, but you can use software to override what your MAC address is. And so even MAC address filtering has some areas of concern. One of the best ways to secure your network is to use authentication and encryption. In the original 802.11 standard, there were two types of authentication that were specified. One was the open authentication, one was the shared authentication. In the open authentication, it's an open network. There's no passwords. Anybody who wants to, they can associate it with it. A lot of times this is that free internet access in a coffee shop or at a restaurant, in a public place where somebody's offering free there. Now, the client has the full responsibility for security. There is no security built into it. You even agree to that when you connect in, saying there's no security here. You are responsible for that. This is where if somebody's connecting to an open access point, I would definitely make sure you're using some sort of VPN to connect into the network to make sure that that traffic is not being sniffed, not being tracked or recorded by somebody else. The other authentication method is shared keys. This is the process to authenticate and then encrypt data between the wireless client and the access point using some sort of keys. Now, the password has to be pre-shared. Now, what does that mean? It could be some sort of certificate on the computer that you as an administrator have to go to the end device to install, or you set up a password or passphrase and then you have to share it or enter it in on the computer. And so it has to be pre-shared is what we're looking at. And the standards here is WEP, WP, WPA2, and WPA3. Now, with the shared key authentication methods, there are typically four we're seeing WEP, the wired equivalent privacy. This was one of the first ones in there, and it was good for its time. But as computational power has gotten a lot more in devices, as they figured out how this WEP works, has been definite holes shot in this. The first person to break it broke it and was able to get into networks. I've seen it where people have been able to get into web networks that run web as an authentication and as privacy in as quick as 30 seconds nowadays. I've been able to do it in under 2 minutes in a testing environment, just to see that I could do it. And shows that it involves intercepting some frames and re-engineering the key backwards. Then the Wi-Fi Alliance came out with Wi-Fi Protected Access. That's WPA. Now, it's definitely more secure than WEP is, but there are some vulnerabilities with it, and that's why we have more advanced versions. WPA is considered insecure. Most companies won't allow you to use just plain old WPA, and it is much better than WEP. It uses TKIP, the Temporal Key Integrity Protocol. It helps. It's a more robust way of encrypting our data. TKIP changes for every packet, making it much more difficult to hack, but yet it still isn't. And like I said, it has been deemed insecure. WPA2 is kind of the industry standard right now. WPA2 uses AES, the Advanced Encryption Standard. It's considered, out of the three we're using right now, the most secure. And most corporate policies say you needed to use WPA2. A lot of times they don't even support the other protocols on their network. WPA3 is a next generation. They're just starting to get more information out about it. They're starting to implement it more on devices. In the coming years, we're going to see WPA3 as the industry standard. Now, what WPA3 does is it's requiring the protected management frames. It's encrypting data. It's checking the integrity of that to make sure that nothing has been intercepted, nothing has been changed in our data. I hope you're liking this episode on securing wireless LANs. If you have the time, please leave a comment and let me know what you think about securing wireless LANs. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Now, there are different methods. Here's a screenshot of a home router. And at home, when we think about setting up encryption, WPA2 should be the way we go. Now, when we choose that up here on our security mode, a lot of times we have WPA2 Personal and WPA2 Enterprise. Now, Personal is intended for the home user, small offices to use it. It uses a pre-shared key. Typically, it's a passphrase that you share with your end users to get in. Ever go into a cafe to get onto their Wi-Fi, they had to give you a password. That's a pre-shared key. That's what we're looking at there. No additional server is needed. The WPA2 Enterprise, this is where you're going to have another server that provides authentication. It could be a Radius server, it could be a TACAX server, it could even be Active Directory, where we have usernames and passwords stored, and in there you can store permissions. Is this person allowed to log on to our wireless network? Yes or no? And you need that infrastructure to support WPA2. When you select your WPA2 Personal or Home, a lot of times you're going to have to choose the encryption, how that data is being encrypted when it's going across there. Your normal choices are AES and TKIP. TKIP, once again, is an older technology. It's a little bit less secure. AES is the more advanced one, has a better algorithm for encrypting your data. You would always want to use AES when possible. Now, sometimes when you're setting this up, you may not have AES available on your end devices, and you would have to go in and set up a TKIP encryption. Setting up at home, I would probably use the WPA2 I would try and make sure I use AES, but if I have some older equipment, I would use TKIP, use a pre-shared key. I'd set up my password. Now, what password do you use? Something to you. Once again, I would use some sort of complexity standards. Uppercase, lowercase, throw a number in there, not a dictionary word. When you're setting up WPA2 Enterprise, this is where you need that additional server. This is where you run some sort of AAA server like Radius that does the authentication, authorization, and accounting. You have your username and passwords and permissions in there. You go in there and you set it up. You use the best encryption possible. Hopefully you can use the AES at this point in time. Then you have to supply it. What server am I connecting to? What's the IP address of it? And you can go ahead, you can type that IP address in there. What port is it using? By default, a lot of times it uses 1645. It could also use 1812 as another port, depending upon what version of Radius and how you set up your Radius server. And then we have the shared key. This is kind of the password to authenticate this access point to use the credentials on there. And notice, it's a very complex password. It's a very complex shared key. From my experience, this is even too short. I would expect to see something even double this length just to make sure it's all secure, because odds are you either have to copy and paste it to put it in here, get it off of your Radius server, paste it in here, or you wrote it down. And if you're writing down 12 characters, writing down 24 characters is just as simple. You have the same implications, except if somebody's trying to hack it digitally, they have to get in that much longer. WPA3 Standard is a new one coming out there. It's evolving. A lot of people are saying WPA2 is no longer considered secure. They've shown theoretically how to crack it. We just don't have the computational power to do it. To crack WPA2, it takes a lot of processing power, more than you would have to do this. Now, that's why they're saying it's no longer considered secure. There's not a lot of red flags up about it right now because we don't have that computational power. But as computers start to get stronger and faster and we have better algorithms to crack this, WPA2 is going to be like WPA. You no longer can use that. And so when we have WPA3, there's a couple different methods here. We have personal and enterprise. The personal one here uses something called SAE, simultaneous authentication equals. And what that does is a lot of times when somebody attacks your network, they use a brute force attack. They try to logically throw numbers at you, random numbers. And so they go through a sequence. They try A first, then they try B, C, all the way up to Z. Once they get rid of that one, then they go to AA, AB, and they brute force that. WPA3 tries to avoid that using this simultaneous authentication of equals. WPA3 Enterprise uses 802.1x and EAP authentication. It's some advanced security you built in there. It requires 192-bit encryption to work. The cryptography or cryptographic suite, 192 bits, and it eliminates mixing of protocols. And what that basically means, if you use WPA3, that's all you can use. You can only use those standards. Now, we also have the open networks here. It doesn't use any authentication, but it will use something we call opportunistic wireless encryption. And what that does is it will actually encrypt the traffic, but there is no authentication to use it. And so that's a little bit different there. It'll encrypt the traffic, but there's no authentication to use it. And then part of WPA3 is IoT onboarding. We use something called DPP, Device Provisioning Protocol. And that allows you to add in a lot of devices quickly. IoT, in the future here, we're going to have lots and lots of devices on our network to monitor stuff, especially in corporate environment. And to bring these all online, we got to make sure we have all the authentication and authorization set up. And so they designed WPA3 specifically to onboard these IoT devices. It was my pleasure to provide you with this wonderful episode on securing wireless LAN. If you like this episode and you got value out of it, please click that like button, give me a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.